Okay, this question says, the table above gives selected values for a differentiable function f and its first derivative. Use the left Riemann sum with 3 subintervals of equal length, using that rather. Which of the following is an approximation of the length of the graph of f on the interval 1 to 7? So I would imagine a lot of students probably get this one wrong. And they probably do that because they probably just think you're doing a good old LRAM under the function. But we're trying to approximate the length of a curve, so you need to recall the length of a curve formula. So the length of a arc length or length of a curve, there's a couple formulas depending on the mode you're in, but it looks like this. It's the integral from, in this case, 1 to 7, and it's the square root of 1 plus the derivative. Okay, usually, dy dx can go there if you recall that formula, but we're trying to approximate this. And so to do that, what we do is this is going to be using our table above, it's going to be about equal to. So using LRAM, right, we just need to just treat this inside as though it's a function and you're finding area under it. Okay, and we'll go to our table to retrieve the values we need. So LRAM is going to say, so we need this distance, right, up here. That's delta x being 2. So that's like the width of our rectangle. And then the height is, since this is what the function looks like, it's going to be the square root of 1 plus, and I'm going to use, right, f prime is in that expression. I'm going to use that 2 there, right, 1 plus 2 squared. So there's like my approximation for the area under the curve from 1 to 3. Okay, and then just move on, do the next section. So this delta here is our change in x, or the width of the rectangle, is 2. And then I use this value, 1 plus 1 squared. And then finally, that delta x is, again, 2. And I use this value here. Again, I'm using the left part, the left hand of every subinterval there. So, okay, and so in the end, we end up with 2 root 5 plus 2 root 2 plus 2 times root 1, which is 2. So that matches letter D.